Hello grade 10s and welcome to this lesson on trigonometry. Now many people dread doing this for the first time in grade 10, but there's no reason to dread it because all we're talking about are triangles. And you've been doing triangles for a long time. Now more specifically, we're only talking about one type of triangle, and that's a right-angled triangle. Remember, a right-angled triangle, one of the vertices is 90 degrees. So it's very easy to spot a right-angled triangle. If you think back to Pythagoras, and yes, Pythagoras will come into this a little, you'll remember that we label the hypotenuse, and the hypotenuse is always the longest line in the triangle. Let's take a look at the triangle I have on the screen. Okay, so there is the right angle that we were talking about. And the line that is opposite the right angle is called the hypotenuse. Now grade 10 says one thing I really want you to pay attention to and to do the first time you have any triangle in front of you. Always label the hypotenuse first. Always, always, always. It will make your life so much easier in this section. After that, you can start talking about the opposite and the adjacent, all of those concepts that you've been talking about in class already. But make sure that hypotenuse is labeled first. Now, the problem that people find with labeling the opposite and the adjacent lines is that it all depends on where you're looking at the triangle from. So I'm going to teach you a little trick. You see, I'm not very good at memorizing things. So I'm always looking for tricks to help me remember things. Let's take a look at the triangle and I'll show you my trick. Okay, so the second thing I do, I've first labeled my hypotenuse and I do a big H over there. And then wherever theta is, which is that funny symbol that's over there, and remember theta is kind of like an X in algebra, but it's theta in trigonometry. Wherever theta is, I draw a little Helen, and as you know, that's my name. So there is Helen. If Helen is standing there, this line is opposite to Helen. So it's very easy for me to go, oh, okay, that one is opposite. And then the other line that Helen is holding is adjacent. And remember, adjacent means next to. So it's much easier to see it if I can actually see little Helen's arms reaching out for the line. Okay, so I've now labeled my opposite, my adjacent, and my hypotenuse. I'm sure you've seen this before, written up somewhere, but this is how I remember the three ratios. So, ka, toa. And you'll probably have heard silly rhymes that help you to remember it, but honestly, I remember the spelling better. Now, the reason we need to know this grade 10s is because you need to remember what the relationships are between the lines. You see, if we put two lines in ratio with each other, we're able to do fancy calculations on our calculator, which will then give us the size of the angle in relation to those two lines. So it's really important we remember which lines we need to use with relationship, within that relationship to that angle. For example, if we're looking from little Helen and we need to find out what little Helen's thing is, let's go back to our diagram. So there is little Helen. We want to know what the size of little Helen is. We need to use one of these ratios. We could use sine is equals to opposite over hypotenuse. And remember, the theta always has to be there. But if we use opposite over hypotenuse, we need to know that it is this opposite line we're talking about. Because if we start talking about, let's say we have a little James over here, and we need to work out what that angle is, his opposite is actually down there. It's not the same opposite as over there. This is his adjacent. So it is quite important that we always say which angle we're looking from.
and that's why we have the theta. Okay, let's go down and take a look at these ratios. And you know them already. We've got sine is equals to opposite over hypotenuse. Cos theta is equals to adjacent over hypotenuse. And tan theta is equals to opposite over adjacent. The next thing I'm going to show you, grade 10s, usually gets a few people flustered, and I've got to be honest, it's not my favorite thing either. And these are the co-ratios. They're the ratios that are the opposite forms of sine, cos, and tan. So sine is opposite over hypotenuse. Its other one, its friend, its co-ratio, will be cosec, which is hypotenuse over opposite. So there we go. We can see that those two are related. Now, it's only in grade 10 that we talk about these ratios. In grade 11, we don't use them at all, and not in grade 12 either. So it's important that you know them for grade 10, but then you can let them go. We don't have to work with them again. We mostly work with sine, cos, and tan. Okay, we're moving on to the special angles or special triangles. Now, we don't actually have any questions on them today, but it's a good thing for you to know. The one triangle has an angle of 45 degrees, and then it has lines of 1, 1, and square root 2. The other triangle has two angles which are important. It has a 30-degree angle and a 60-degree angle, and it has sides that are 1, square root 3, and 2. Grade 10s, you must be wondering why you need to know these. Well, I like to tell a story about a long time ago, which actually really wasn't that long ago. It's probably about 30 years. Calculators couldn't do as many things as they can now. And so we found these special triangles, and by we, I'm not meaning me because I'm not that old, but we found these special triangles that then allowed us to reduce angles quite easily and change them into their fraction values and all sorts of things. You need to know these triangles off by heart so that if someone asks you what sine of 30 is, and let's look at what sine of 30 is. So I'm going to draw my little Helen around 30, and sine in SOHCAHTOA is opposite over adjacent. So I first label my hypotenuse, then I can see, oh, my opposite is where Helen can see, so there we go. So sine of 30 is equals to 1, because that's my opposite value, over 2. So as you can see, sine of 30 has a very nice answer. Cos of 30 will also have a very nice answer, as well as tan, and the same with 60. Same thing can be applied to 45 degrees. Now, when you put all of these on the Cartesian plane later on in the year, you'll see that we're also able to extend these special angles, not the triangles, the angles, to 0 degrees and 90 degrees. But we'll have more fun with that later on in the year, and trust me, it's a lot of fun. So look forward to it. Shall we begin by looking at the challenge question for this week? And remember, the challenge question, we're going to go over all of them at the end of the term in our revision thing. So why don't you take a minute and copy down the diagram and attempt it this week.
Okay, so I hope you've copied it down and we will go through it at the end of the term. Let's start with our first question for today. And we're going to look at this triangle. Write two solutions. Watch out for that. It says 2. For each of the following trig ratios in terms of the sides of the triangles. How many triangles do we have here? Here's one. Okay, and let's take another color. Here's another. Oh, and we have a third one. So we are using 3 different triangles over here. All of them are right angle triangles. We can't do trigonometry at this stage without right angle triangles. So you need to write down 2 solutions for sine B, for cos D, and for tan B. Why don't you take a minute and do it yourselves. Okay, let's see if you got them right. We'll go to the next page where I've got more space and start with sine B. So I'm going to draw little Helen around the angle B so I can figure out where I'm looking. Now they want 2 different answers. So I'm going to have one fraction over there with an answer, and then let's do another one just underneath it with another fraction. That's a fraction line, not a minus. Okay, so sine B, let's start first with this small triangle. And remember, the first thing I'm going to do is label the hypotenuse because that makes it easier to see the other lines. Sine is opposite over hypotenuse. So the other side we need is the opposite side. Let's look, and she's looking across the room and she sees the opposite line is actually AC. So that means sine B can be equal to, and let's just give ourselves a little bit of space, AC over AB. How did you do? Hopefully you got the same answer. Okay, but they've asked for 2 answers, so let's do the other one. We're going to take another triangle that B is a part of, and that's this bigger triangle. And I've chosen pink because, of course, the bigger triangle has a different hypotenuse. Sine is opposite over hypotenuse, so little Helen looks across the triangle and sees her opposite line at the bottom, which means that sine B in this case is AD over BD. Grade 10s, before we go on to the next one, it's time for you to have a little bit of a break. Shake out your legs, stand up, walk around, sit down, and get ready to do the next step. We'll see you soon. Okay, grade 10s, while you were away, I was a little busy. And by busy, I mean I was just erasing my diagram so that we could work on it for the next question. Now, the next question asked us to find 2 ratios of cos D. Let's see how we do. So, once again, I am going to draw little Helen around the D. And the reason I do this is because it's easier for me to see where the opposite and adjacent sides are then. I'll start with the small triangle,
And of course, in this small triangle, the right angle is over there, which means my hypotenuse is this line down here. Now, if I'm looking for cos d, that's going to be adjacent, and look up over here, it's going to be adjacent over hypotenuse. Hypotenuse, not hypotenuse. Okay, so my adjacent line is this one. And that means we can write down the ratio. And I'm going to squeeze it in over here. It's adjacent, so DC, and you could write it as CD as well, over hypotenuse, which is AD. I hope you got that right. Let's do cos D in a different triangle. Now this different triangle is going to be the bigger triangle, so let's draw it in blue. And of course, the right angle in the other triangle is over there. So let's put the hypotenuse there. And cos is adjacent over hypotenuse. There it is. So we put our adjacent over here, and it's easy to see because it's next to little Helen. So that means our adjacent is AD and our hypotenuse is BD. I'm sure you're getting the hang of this very easily, aren't you? You see, it's not so bad. It's actually quite friendly. I'm clearing the diagram because our next question asks us for tan B. So we're going back up here. Once again, I'm drawing little Helen. And little Helen just helps me to identify my hypotenuse and my adjacent and my opposite. Okay, I'm going to start with the smaller triangle that's connected to the angle B. There's my right angle, and that means that this is my hypotenuse over here. If I want to use tan, we'll go up to this, and we'll see that tan is equals to opposite over adjacent. So I need to figure out which line is opposite and which one is adjacent. I always find it easier to mark the opposite one first, because it's easier for me to think of myself looking across the triangle. And then whatever's left over is obviously your adjacent. Okay, so that means that tan B is AC over, because it's opposite, BC. Okay, now let's do from the other triangle's point of view. So I'm drawing it in green. I'm going to draw in the right angle because the right angle determines where the hypotenuse is. And now I need to determine which line is my opposite. Well, little Helen is standing over there. Look, we'll draw some hair on her. So that means the opposite line is this one over here. And the adjacent one is the one that's right next to her. So tan of B can also be equal to, oh, and my handwriting went very untidy there, I'm sorry, AD over AB.
Okay, grade 10s. Often people are surprised when they find these kinds of questions in tests and exams, but they are very real questions and things that you can actually have in tests and exams. Doesn't that make you feel good? If you just know where to label your opposite and adjacent, you'll be fine. And remember, you must know SOHCAHTOA. So that sine of theta is equals to opposite over hypotenuse, cos of theta is equals to adjacent over hypotenuse, and tan of theta is equals to opposite over adjacent. Okay, let's move on to the next question, and this question is going to require your calculator. I'm going to give you 2 minutes to try each one of these yourselves, and then we'll go through and do them together. Take a look and begin. Okay, the first question should have been quite easy for you to do. The next two are a little bit confusing, but confusing doesn't mean difficult. It just means you need to think a little bit. Okay, the one tip I can really give you, and you really must pay attention to this, is try and use your calculator only once and only round off your answer right at the end. But of course, if you're only using it once, there is only 1 point for you to round it off, so it'll be fine. Okay, let's go through these. The first one asked for tan Q, and it is equals to 0,218. So we go to our calculator and we make sure it's in degrees, which it is. I'm going to press the shift button and get that on screen. And the reason I do that is because I'm solving for the size of the angle. And when I'm solving for the size of the angle, I need to do it. And that means Q is equals to 12,298. I'm going to round it off to 12,30. So I just write over here, Q is equals to 12,30, and then of course it's degrees. Okay, the next question, slightly more complicated. We need to first isolate cos Q. Now, if you find this confusing, I want you to think back to algebra. When you had a problem like this, what would you do? Well, you'll remember that I spoke about getting the girl, or the boy. If you want to get the girl, you first have to get her alone. So we need to get rid of her friends. So that means we've got 5x is equals to 4. And now that we've got rid of her friends, we need to get rid of her inhibitions so that she'll laugh at our jokes and say yes to the date. Which means that the 5 is multiplying on that side, so it's going to divide on this side. The same thing is happening over here. Except instead of it being x, it's now cos of q. So let's solve this, and we'll go back to green. Now we need to get cos q alone, which means we need to move the 4. The 4 goes to the other side. It was minusing on that side, so it pluses. And now we need to get rid of the 5. And the 5 is multiplying cos q, which means it's going to divide on the other side. Now that we have cos q isolated, we need to use our calculator. And here's our calculator, so I'm going to clear it. And because we're solving for an angle, we press shift and cos, and then in the brackets, I'm going to write 4 and 5. Now remember, some calculators are really fussy that you close the brackets, so make sure that you do. Okay, so in this case, Q is equals to 36.869. I'm going to round it off to 36.87. Let's write that down. Therefore, Q is equals to 36.87 degrees. Okay, the last one would have scared a few people because of that fraction. But there's no reason to be scared of it. Why? Because it's just a fraction. So, if we want to get the girl, and in this case, the girl is sine 2q. So let's write it as a normal equation over there. We would take the half over, so we're left with negative x is equals to negative half, and then we would get rid of the negative, and x is equals to half. But it's not an x, it's actually sine 2q. So let's do it over here. I'm going to take the half over to the other side, leaving me with negative sine 2q is equals to negative half. I don't like the negatives, so I'm going to get rid of them, and the way I get rid of them mathematically is I'm multiplying both sides by a negative 1. Okay, grade 10s, by this point you should be looking at it and going, but usually it says sine q and not sine 2q. And you would be right, it does usually say that. But in this case, they've thrown the 2 in just to see if you can think a little outside of the box. So the next thing we need to do, now that we've isolated the sine ratio, is we need to use our calculator to figure out what 2q is as a value. So let's whip out the calculator. There it is, and we'll clear the screen. Because we are calculating the size of the angle, we use shift and sine, and then we have 1 over 2 in the brackets, and we close it, and our answer is 30 degrees. And actually we did that earlier, didn't we? So we should have actually known that. Let's minimize it and say, therefore, 2q is equals to 30 degrees. So our next step, now that we have the value of 2q, is to get rid of that 2. And as you know, it is multiplying q, which means we're going to divide both sides by q. And I've drawn in a step that I don't usually draw in. I usually just say we're going to divide the other side by 2, but I thought, why not today? So that means q is equals to 15 degrees. Okay, these calculator questions are definitely going to be in some tests and exams because it's important that you know how to operate your calculator. If you don't have a calculator, you need to find one that you'll be able to use in tests and exams so that you can get used to how to punch in the numbers. And different calculators do operate differently. Some of them aren't as nice as you just put in what you see. Sometimes you have to do it a bit backwards. Anyway, I'm sure you can approach your teacher for help, otherwise a friend, or go online. Okay, so now we're going to look at the next question. And these are a series of triangles. And we're going to start just with A and B. I'm going to give you a minute to draw them and then attempt them. On your marks, get set, go. I hope you started by marking off your hypotenuse and then figuring out where little u was standing so that you could mark off your opposite and your adjacent. Okay, let's take a look. So the first thing I'm going to do in both of these triangles is to mark off my hypotenuse. The question says find the length of the unknown side in each of the triangles below. So that must mean I need to find the size of A and the size of B. Where is little Helen standing? Well, she's standing in the only place that seems to be important. And the reason I know it's important is because there's actually an angle written there. So it makes sense for me to draw it there. Now, if I'm looking across the triangle, that means this side is opposite and this side is adjacent. And over here, if I'm looking across the triangle, this side is opposite and this side is adjacent. Okay, but now we need to look at what we have. We have the information for O and for H, which means we're going to use sine, and the information for O and for A, which means we're going to use tan. Now, grade 10s, before we get to this answer, you need to take a bit of a break, stand up, breathe, and we'll see you just now. Are you feeling refreshed? You ready to get back into this? Now remember, we were looking at two different triangles, so they were two different problems, but I was showing you how the same skills apply to both. We labeled the hypotenuse, the opposite, and the adjacent according to the information we were given. And then I circled the important things. In other words, the parts that we're going to be using in these questions. So yes, we know which side is the adjacent, but do we really need to use it? Let's go and look at the question. So now I'm just going to focus on this first question. And the adjacent is not important. And the reason I know it's not important is because there's nothing written there. Only my opposite and hypotenuse. And if I remember SOHCAHTOA, and I'll just write it over here, I know, that's an A, not an H, I know that sine has the opposite and hypotenuse. So I must be using sine of theta. But it's not theta I'm using, is it? Because look at what's in little Helen's head. 37 degrees. So sine of 37 degrees is equals to the value of the opposite is A, and the value of the hypotenuse is 62. So now we need to solve the equation. The real question is, who is the girl in this equation? If you said A is the girl, then you would be right. That's what we need to solve for. So we need to get rid of the 62 and have A all on our own. And the way we're going to do that is 62 is dividing on that side, so when we move it over, it's going to multiply. So that gives us 62 times sine of 37 degrees is equals to A. And I'm not sure about you, but I definitely can't do this in my head. So let's open up our calculator and we'll put in 62 times by sine, and on this calculator you don't need to put the sine, and we put 37, sorry, calculator malfunction, 37, open brackets, press our equals, and our answer is 37,31. We'll round it off to 37,31. So that means the length of A is 37,31. Not too bad. Now, if we look at the second question, the hypotenuse is not really important because we're only given information for the opposite and the adjacent. And that means we're going to be using tan because tan is opposite and adjacent. So tan of theta is, well, are we using theta? I hope you said no, because here's little Helen, and what does she have in her pretty head? 23 degrees. So 23 degrees is equals to opposite, which has a value of B, over adjacent, which has a value of 21. Well, once again, we're solving for an equation, but which part are we solving for? If you said B, you would be correct. So we need to get B by itself. 21 is dividing B, which means it's going to multiply on the other side. And remember, we're not just multiplying the other side, we have done mathemagics here, and we've multiplied both sides by 21. Let me just show you that quickly, so that we've multiplied this side and this side by 21. And the reason we've done that is because that 21 will cancel with that 21, and then the other 21 will multiply the tan. So now we can't do this in our heads, we need our calculator. I'm going to take out the calculator and move it across. Whoa! And let's clear the screen. 21, try again, 21, tan of 23 degrees, 23, close brackets, is equals to 8,91. So let's write that down. B is equals to 8,91. Okay, grade 10s, let's go on to the next questions. Now they are very similar. I'm going to give you another minute to try these by yourselves. a minute really does go fast, doesn't it? I'm sure you finished them by now, though. I'm sure it was quick. Let's see how you did. Okay, so it's the same phrasing of the question, the length of the unknown side in each of the triangles below. I'm going to start by drawing myself. There's little Helen, and then label my hypotenuse. Now I know that this side is opposite because I look across the triangle at it, but it's not important. My adjacent is what's important, and I know that because the adjacent has a value and the hypotenuse has a value. So if I look at SOHCAHTOA, and I just want to encourage you to write this at the top of every single page in your trigonometry workbook, as well as on the top of every single exam and every single test, SOHCAHTOA, so that you can remember it in stressful situations. So according to SOHCAHTOA, adjacent and hypotenuse forms part of the cos ratio. So that means cos of 55 degrees is equals to c over 19. We need to solve for c, so we're going to multiply both sides by 19, giving us 19 cos 55 degrees is equals to c, and then we need our calculator to do it. The calculator needs to wake up, and we'll move it across, and let's type it in. 19 times by cos of 55 is equals to 10,897. So I'm going to round it off to 10,90. Therefore, C is equals to, and I can put the therefore sign there. Therefore, C is equals to, and I've forgotten, 10,90. 10,90. Now C is a length, so it's not degrees, it's just in units. Let's do the other one, and I'm going to start by drawing myself. Hello, Helen. We put you over there. The hypotenuse is over here. Now once again, I could label the opposite, but it doesn't seem to be important. It's only the adjacent that's being used over here. So let's figure out which ratio that is. And I'm sure you can see immediately that this one is also calculated using the cos ratio, adjacent over hypotenuse. So cos of 49 degrees is equals to adjacent, which is d, over hypotenuse, which is 33. And once again, we're going to solve for d, so we're multiplying both sides by 33 to get d alone. And then, can we do this in our head? No, we can't. So we call up our trusty friend. Let's move it across. And 33 cos 49, 49, close brackets, is equals to 21,65. So that means D is equals to 21,65. Let's just check that. I'm not sure if I wrote down what I was thinking. Yes! Perfect. Grade 10s feels good, doesn't it? Okay, the next question we're going to do has words in it. And many people feel like word problems should be really, really difficult. And as a result, they don't really attempt them. Now, that's not the case in trigonometry. If you get a word problem in trigonometry, what they've done is they've taken a really easy problem and have tried to make it look difficult by throwing words at it. But now that you know the trick, you don't need to be scared, do you? So let's take a look at this word problem and see what you can figure out. It says a ladder of a length of 15 meters is resting against a wall. The base of the ladder is 5 meters from the wall. Find the angle between the wall and the ladder. Okay, grade 10s, the first step in this question is to picture what is happening. So close your eyes. Have you got them closed? Good. Now I want you to picture a ladder that is 15 meters long or in length. Now I want you to picture carrying this ladder to a wall, but stopping 5 meters before the wall and then dropping the ladder so that it leans against this wall. Okay, grade 10s, I'm going to give you 1 minute to draw a diagram of this. You can make it as pretty as you like, but you must include the degrees, not the degrees, we're not given any degrees, but you must include the 15 meters, the 5 meters, and which angle we need to solve for. So we're going to show the question, and you've got a minute. On your marks, get set, go. I would love to see what some of you have drawn. Now the trick with mathematics drawings is to make them as simple as possible, and that's the trick with most mathematics. Mathematics is there not to make you stressed out, but to make your life more simple. So when you've drawn the diagram, you need to look for the triangle that's there. I'm going to draw how a mathematician would draw this problem.
Okay, so it talks about a ladder that's 15 meters in length. So I'll start by drawing the ladder, and I'm just going to label that it is 15 meters in length. And the reason I've drawn it at an angle is because it is resting against the wall. Oh, and my wall wasn't made very well, but oh well. Now the wall is obviously at a right angle to the floor, so I'll put that in. The base of the ladder is 5 meters from the wall, so that means where the ladder is based is over there, and that is 5 meters from the wall. The last thing I asked you to put in is the angle between the wall and the ladder. That can only be this angle over here. So I'm going to label that angle theta, and I am going to solve for it. Now theta, let's just make it into a little Helen. There's my hypotenuse, and she's looking opposite her, so that means my ratio I'm going to use is sine of theta, and it's equals to opposite, which is 5, over hypotenuse, which is 15. Now we need our calculator, so we take it out and we type in sine, and I made a boo-boo. Because we are solving for the angle, we press shift sign, and then we put 5 over 15, close the brackets, whoops, and we're almost done with this. And we get an answer of 19,47. So that means theta is equals to 19,47 degrees.
And there we go. Now grade 10s, that really is how difficult trig is going to get at this stage. So if you practice it, you will be fine. There is nothing to be scared of. You will just blossom. But practice is the key. It is always a pleasure being with you. I hope that you've been revising all of the other things that you've done this term, like your factorizing and your products and your exponents, because all of those things are going to be revised in the last lesson of the term, which I think is the next one. So enjoy the rest of your week, and we'll see you then. Bye.